Hello everyone, this is our Gearbox project. Group members include Christopher, Stephen, Isru, Ilya and Alex. My name is Ilya. I was responsible for the gearbox case construction and all of its design in SolidWorks. Here's some of the views that you can see, the isometric view, the front view and side view. Just gives you a rough idea of the layout of the case itself. Here's some of the features designed into the case, such as the mounting holes and locking mechanism that all parts use to interchange with each other to hold the case structurally rigid. The two mounting holes are the ones on the outside there on the left image. In the middle image we have the exit for the wire that's coming off our last shaft, which is not present in this view. And then on the right hand side we have the mount for the motor. I'll pass it on to Alex and he'll be able to explain more.
G'day, my name's Alex Bowman. My task in this gearbox project was to create all the spur gears. Here you can see I created a 61, 57 and 54 two-spur gear. The way I created these spur gears is I used the equations function in SolidWorks. Here I was able to add all the equations in relation to spur gears. From here I was able to make a sketch and then link the dimension of that sketch to these equations, which would change them accordingly. There are other couple of ways you could make spur gears in SolidWorks, but I chose this method as you can completely customize the way you like your gear, and you could also, after you've made the first gear, it's so easy to make another gear. The only things you have to change is the pitch circle diameter and the number of teeth. I also use this to create our pinions. Here you can see how I created the involute tooth profile. I used the equation-driven sketch function in SolidWorks. Here I added in the following expressions, and then after this I was able to do an extruded cut, which gave the profile for the teeth.
Hello, I'm Chris, and I've done the animation for the gearbox that we've got here that Elia and Alex have put together for us. So we're just going to do a quick exploder view to see all the parts individually and how they kind of fit together. So we'll zoom in on the gears first, and we'll just check out all the different ratios there. We've got the hole that we wrap around the wire to attach to the weight. We've also got the motor mount here, and if we go down, we've got the M6 bolts right there for that, and up top we've got similar holes to spray in the lubricant just to make sure the gears don't get too frictiony and too hot. We don't lose too much. We've got another zoom in there on the hole for the wire to shoot out to the weight, and that was our neat little gearbox. Thanks. Hey guys, it's still Chris. Got another animation for you just to show a simulation of the motor step down and the ratios and how they're affected on each step down. Now we've got it actually set at 100 RPM, not at the 9,679 RPM that the motor actually runs at, just so we can actually witness each step down. So otherwise it was just too fast and we weren't able to actually see the contacts very well. So there was a quick zoom in there. You could see it looks like its contacts are well. The teeth are going at the expected ratio that we wanted. But if you actually zoom right in, perfect, we can see that there is no intersecting. It's got a nice good contact. Hopefully not much efficiency loss. You might have noticed the shadows were bouncing around a bit during that animation. That's just SolidWorks. I don't know what to tell you, but that was our neat little animation for our box. Thanks.
Alright, thank you. My name is Stephen, and I'll be covering the finite element analysis, which was both my responsibility and Isru's, who also helped out with this section, but only one of us will be speaking since these are pre-recorded. So firstly, for the FE analysis, we wanted to cover several aspects of the gearbox. Most importantly was ensuring the gears can handle the stress. So we wanted to do an analysis at each of the 3 gear mesh steps to ensure that they were each up to scratch. By using the worst case scenario is how we want to go about. So that would be where the secondary gear becomes completely jammed and won't move. Thus the first primary gear would transfer all of its torque onto the secondary, which would give the maximum tooth stress. So this would ensure that if it passed this test, there'd be no failure of the gears under any reasonable circumstances of operation. The gearbox case was also to be checked to ensure it was capable of holding the motor with the just 2 screw connections existing for the motor, and also further checking the 2 mount points are capable of holding the case, considering the moment that it receives from the weight of the motor, as well as any moment from some horizontal forces coming from the weight or ropes if it was to be snagged, or in startup of motion when it's still under static friction where it undergoes the most force. There may be a little bit pull on it. Chances are it won't affect the case, but it's still worth a check. The shaft should also be considered, particularly the output shaft, for similar circumstance. So this is ensuring that the maximum force output would not deform the shaft. So because it is attached through a hole, if it was to become snagged or during startup with the maximum force, making sure that it didn't deflect at all and it wasn't going to unmesh the gears or have any negative effects, and also making sure it can just hold up the weight of the gears, because in normal operation the shafts won't undergo much more stress than that. So onto the FEAs that were actually produced. So the results we managed to produce were just on the last step, or the last mesh, which is between the pinion and the 54 tooth gear, which is the smaller of the gears. And that was chosen as a priority due to experiencing the highest torque, being that it's at the last step and attached to the output shaft. So a torque of 0.16 Newton meters was used, being the presumed torque they'll be required to move the weight. And unfortunately, the result did show that it was over yield for acrylic. The stress is very localized, or located around just the tooth in contact, and this is representing the worst case scenario within reasonable operation as well. So during regular operation, likely that these amounts wouldn't actually be reached, but in a worst case scenario, it would fail. Displacement was minimal at only 0.27 millimeters, which means there's very little movement within the gear mesh. So it would really only be it works or it fails catastrophically. So close up on the next slide there shows just more zoom in version, where you can see the stress is very localized to the tooth, just joints in the corners, and the displacement is quite minimal. So being able to either round off those corners or apply mesh control, actually bring those numbers down and bring the stress below yield. So unfortunately, not any more FEAs were produced. So finally, I'm going to touch on the problems that we had come across. So Isra and I both had 2018 SolidWorks due to having subjects in it previously, and they were not compatible for 2019 SolidWorks that was used on the Gearbox, which we really think about or come across until it was a bit more later on, and neither of us were able to upgrade or install the new version. Just purely had some errors on both our ends, which is a bit unfortunate. I managed to use tricks to get access to 2019 SolidWorks, and I then got to the mission stage of these years, but with many hours of trying, we were able to perform the final solve, the measure, and then once the final solve, it just freezes there indefinitely, and we are first step. So through mesh travel friends in place, access to the computer had 2019 SolidWorks on it. So definitely thanks to him, he was able to pretty much run the FEA that prepared through tricks, and as a result also. There is still a lot to do in terms of completing the FEA work that we want to have to get a complete accurate representation of how the Gearbox will perform. And despite the results from the FEA, I do have reasonable confidence that the gearbox would still be able to perform properly under the normal working conditions. Thank you for your time, and any questions, please.